Welcome back. So obviously, there's no point in somebody seeing this lesson unless they've seen the previous lesson where I discussed about properties of a binomial theorem. But if by any chance you've joined just now, only for this lesson to look at the examples, I presume you know what it is. Anyway, by the way, I am Sosale Mohana. I'm a maths teacher with over 50 years of teaching experience. I'm just going over the topics in A level for the benefit of students like you. So coming back to this, in the last lesson I talked about the properties, so I have listed all the properties here. So I'm going to show some examples on binomial expansion. That is what I'm going to do. Right? To go over, if you are expanding x plus a power n, total number of terms will be n plus 1. It always starts with x power n, always ends with a power n. The total power in any given term is always, the power of x plus the power of a will always be n. And the coefficient of any term depends upon the power of a. Suppose you have a power 7, it will be nc7. And the general term or the r plus 1th term, which is the most important one, is that. So in other words, if you are asked to do an expansion, I would use this than the formula in the formula book. If you are asked to find a particular term, then I will use this. I'll show you with an example. For example, let's say expand and simplify. Expand and simplify 3x minus 2 to the power 5. Yeah. So I start with property number 2. So 3x minus 2 power 5 will be, it starts with x power n. So 3x power n, please understand, I've seen many students in tests not putting a bracket. Learn to put a bracket. 3x power n, which is 5, and then it ends somewhere with minus 2 power 5. So I got the first and last terms. Total number of terms is n plus 1. N is 5, so I need 6 terms. I got 2. So I need 4 more terms. So 1, 2, 1, 2, 3, and a 4th term. So I've got to now do 4 terms, right? Second term, third term, 4th term, 5th term, and 6th term. So I need one more here. Okay. The power, I forgot the total. Oh, I forgot to write one more property there. I can add it here. The powers of x decrease as the powers of a increase. I think that's the easiest way to remember. So power 5 becomes power 4, then becomes power 3, then becomes power 2, then becomes power 1. Okay. Then the total power in any term is n. So if it is power 4, I need a minus 2 power 1. Power 3, I need a minus 2 power 2. Power 2, I need a minus 2 power 3. Power 1, I need a minus 2 power 4. 1, 2, 3, 4, 5, 6 terms. Perfect. The coefficient now depends upon a. A is minus 2. Minus 2 power 1. So 5c1. Sometimes we write 5c1 like this, which is 5c1. Power 2, 5c2. Power 3, 5c3. Power 4, 5c4. Power 5 is 5c5. Power 0 is 5c0, which are both 1, so I don't bother. Now I have to simplify. Now you have to use your calculator. I don't have the calculator. You will see, I don't know where it is. It depends upon different calculators. On my scientific calculator in the computer, on my mobile, I think the NCR button is, since it is the same app as that of a standard calculator, I don't think it will be different in yours as well. Open your calculator. Look at, if you have a mathematical or scientific calculator, look at the number 2. Above 2, in yellow or in red, you see the word NCR. So if I want to find 5C1, how will you use your calculator? So you write 5 NCR1 equal to. So 5 shift NCR, because if you press 2, you're going to get 5 and 2. Whereas shift and press 2, you get the letter C, 5C1. In the calculator now, I see that as 5C1. 5C1 is 5. 5C2 is 10. 5C3 is 10. 5C4 is 5. You can find those, or if you 5C2 is 10, that's good enough. So therefore, I rewrite this as 3 power 5 x power 5 plus 5 times 3 power 4 x power 4 times minus 2 plus 10 times 3 power 3 x power 3 minus 2 squared plus 10 times 3 power 2 x power 2 minus 2 cube plus 5 times 3 power 1 x power 1 minus 2 power 4 plus minus 2 power 5. The coefficients, this is a cross check. From equidistant from both ends must be the same. The first is 1, the last coefficient is 1. Second coefficient is 2, first and the second, last and the last but 1, the coefficients are 5. 1, 2, 3, third from the left is 10, third from the right is 10, so my expansion is correct. Then what you do is use your calculator, multiply 3 power 5, multiply all this, so it will be plus, minus, plus, minus, plus, minus. Be careful, common errors are, students forget to raise 3 to the power. The second common error is you forget to account for the minus sign. That is how you apply binomial theorem. But if you're not comfortable, just use the formula book. You got x plus a power n and use it. Nothing wrong. But I find using properties makes life easier. And this is for people who might be planning to do further maths. When you can do de Moivre's theorem, you come across expressing cos 5 theta or sin 5 theta in terms of powers of cos or sin. Or you also come across cos power 6 theta equal to cos 4 theta minus 3 cos 2 theta, where you use z plus 1 over z power 4 or z plus 1 over z power 6. At that time, we'll be using binomial theorem. And my experience has been, whenever I start doing for the maths and I come to that topic, I ask my students, what is z minus 1 over z power 4? How do you expand it? I only get the answers and in most of the cases. Why? Because they have done it way back in year 12 in the first term, so they have forgotten. So people doing further maths, remember these properties. You will be using them when you want to do complex numbers. Alright. The next question which I am going to do is straightforward. I haven't seen this recently in the Edexcel papers. Maybe they could be in one of the AQA or CIE or OCR or ACL's papers, just out of interest. For example, I want to find the term in x power, I just have to make up 12, 1, 10, 2, 8, 3, 8 minus 3 is 5. In x power 5, in the expansion of x squared plus 2 over x power 7. Well, one way of doing it will be expand the whole thing and simplify. And then pick the term you want. What if the power of 17? You'll spend the whole exam doing one question. So, we compare this with x plus a power n. X is x squared. Your a is 2 over x. Your n is 7. Right? Now, you assume that the r plus 1th term has the power you want. So, let r plus 1th term have, I don't know if this will work, I'm hoping it works, have x power 5. I need to find that term. What is the formula for r plus 1th term? N CR x power n minus r a power r. So that will be 7 CR x squared power 7 minus r 2 over x power r. That particular term should have x power 5. That means when I simplify the powers of x, I should get x power 5. Now this is the moment of truth. Remember, I make up these questions mentally. So I'll rub this out. Don't worry, examples will be in the notes, so you don't have to bother. So I'm interested in that term. So let me rub this off. So that will be 7 CR x squared power 7 minus r is x power 14 minus 2r times 2 over 2 power r over x power r. That's the term, right? So that will become 7 CR x power 14 minus 2r times x power minus r times 2 power r. Very good. So now let's simplify that. Remember, I need x power 5. So therefore, what will the r plus 1th term become? So r plus 1th term is 7 CR 2 power r. Look, when you multiply two powers of x, you add them. 14 minus 2r minus r is x power 14 minus 3r has x power 5. So, I can say x power 14 minus 3r equals x power 5, which gives you 14 minus 3r equals 5, 3r equal to 9, r equal to 3. 3 plus 1, so I need the 4th term. Anyway, you do that's out of interest, but you can, therefore, the term is 7 C3 2 power 3 x power 5. 7 C3, 7 times 6 times 5 over 1 times 2 times 3 times 8 x power 5. 2 and 3 cancel, 35 times 8, 240 plus 40, 280. So the term is 280 x power 5. So when you want a specific term, it's easier to use a general term and figure out what the value of r should be. Otherwise, you can do always first term, second term, third term, fourth term. What if it was something like x power minus 12 or something? I'm not too sure whether it works here. Maybe x power minus 4, then you will be stuck because you won't be able to do it. You have to do the whole expansion. Maybe remember, power 14, power 7 will have 8 terms, so you have to do the 7th term most probably. I'm just guessing. So, whenever you want a specific term, use the general term formula. When you want to do an expansion, use the properties, but that's only a suggestion. You're welcome to do it whichever way you want. Sometimes they say term independent of x. Especially in Indian syllabus, they ask term independent of x or the constant term. Then what you do is, you put this equal to x power 0. So, term independent of x or constant term. X means it has x power 0. In this case, it wouldn't work because if I put 14 minus 3r as 0, I'm going to get r as a fraction. So, it wouldn't work in this case. For example, if it was x squared minus 1 over x squared power something, it might have worked. So those are examples, and so all these things and similar examples you will find in the handout. I don't want to do any more questions on this. I've just shown you some examples how to use the binomial theorem expansion. I forgot to mention, I should have mentioned, but you see the powers I have used are only positive powers. So whatever I have discussed are applicable only to positive whole number power. If it is a negative number or a fraction, it's a different cup of tea, which we'll take it up later. Okay? Thank you very much. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.